Imagine opening your front door one morning and finding an entire planet drifting silently through the darkness. No sun, no sunrise, no glowing horizon. Just a gigantic black sphere floating across the stars, like the universe accidentally forgot where it parked it. That sounds like the opening scene of a horror movie. It's actually a real thing. Astronomers call them rogue planets. They're planets that don't orbit any star, they're just wandering alone forever. Which somehow makes space feel even less friendly than it already was. Most planets are well behaved. Earth circles the sun, Mars circles the sun. Jupiter circles the sun while showing off because it's enormous. Everything follows predictable paths. Then rogue planets show up like the cosmic equivalent of shopping carts, abandoned in the middle of a parking lot. Nobody knows exactly how many exist. Some estimates suggest there could be billions of them in our galaxy alone. Possibly even more rogue planets than stars. Think about that for a second. The night sky might be packed with invisible worlds drifting through complete darkness, and we'd barely notice. Because they are almost impossible to see. Planets don't produce their own light. Normally we find them because they pass in front of stars or reflect starlight. A rogue planet has neither advantage. It's like trying to photograph a lump of coal floating in a cave at midnight while blindfolded. So where did these lonely planets come from? Usually, violence. Early solar systems are surprisingly chaotic. Baby planets constantly shove each other around through gravity. One massive world gets a little too close, another gets slingshotted, eventually. One unlucky planet receives the ultimate eviction notice. It's launched completely out of its home system, no appeals, no moving truck. Just endless interstellar exile. Gravity is incredibly patient. A single close encounter can change an orbit forever. Imagine two ice skaters grabbing hands, one suddenly lets go. The other goes flying across the rink. Now replace the skaters with planets, and the rink with space. Congratulations. You've accidentally created a rogue world. The terrifying part isn't just that these planets exist. It's that they could pass relatively close to us, without glowing like giant warning signs. Fortunately, close in astronomy still usually means absurdly far away. Space loves making terrifying things feel mathematically inconvenient. Some rogue planets may even have moons. Imagine standing on one. There is no sunrise ever. No familiar star warming the sky, just permanent darkness. The stars overhead wouldn't even slowly rotate around a bright center the way ours do. There wouldn't be one, just endless black. If the planet somehow retained enough internal heat, perhaps from radioactive elements deep underground, life might theoretically survive beneath thick ice in hidden oceans, which somehow makes the situation even creepier. Imagine an entire ecosystem existing under miles of frozen darkness, completely cut off from every sunrise that has ever happened. Then your brain starts asking dangerous questions. Could one wander into our solar system? Technically, yes. Would that be catastrophic? Probably depends on how close it came. A massive object passing nearby could disturb the orbits of comets and asteroids. Thankfully, the chances are extraordinarily small. Space is unbelievably empty. The average distance between stars is so huge that even wandering planets spend most of eternity surrounded by absolutely nothing. Still, the idea is unsettling. Earth feels stable because everything around us appears organized. The sun rises, planets orbit, the moon behaves itself. Then astronomers casually mention that countless giant frozen worlds are drifting through the galaxy without destinations. Suddenly, the universe feels less like a carefully designed clock, and more like a giant room where somebody keeps rolling bowling balls across the floor. Even stranger, rogue planets remind us how temporary planetary systems really are. We like imagining our solar system as permanent. It isn't. Given enough time, gravity changes everything, stars evolve, orbits shift. Galaxies collide, entire worlds can simply leave. The universe doesn't really believe in assigned seating. If you somehow watched a rogue planet pass close by from a safe distance, it would probably be eerily quiet, No dramatic explosion, no fiery entrance. Just a massive black globe sliding across the stars, silent, slow, ancient. Like something that has forgotten what sunlight feels like. Basically, rogue planets are proof that even planets can become homeless. And the universe barely notices. Let's play a completely terrible game. Imagine taking Mount Everest, every skyscraper on Earth, every ocean, every continent. Then crushing all of it into something roughly the size of a city. Welcome to a neutron star. These objects are so absurd that they sound like someone accidentally typed too many zeros into the laws of physics. A neutron star forms after a massive star explodes in a supernova. Normally, stars spend millions of years balancing two forces. Gravity pulls inward. Nuclear fusion pushes outward. It's like the most violent tug-of-war ever invented. Eventually, the fuel runs out, fusion stops, gravity wins. And gravity is a spectacularly bad winner. The star collapses so violently that protons and electrons get crushed together into neutrons. Matter itself changes. Atoms, the things making up literally everything around you, are basically destroyed. What's left is a gigantic ball made mostly of neutrons, packed unbelievably tightly together. The density is almost impossible to imagine. A single teaspoon of neutron star material would weigh around 1 billion tons, 1 teaspoon. Imagine making coffee with that. Actually, don't. Your kitchen would immediately become a geological event. If Earth somehow became a neutron star without changing mass, which thankfully can't happen, it would shrink from nearly 13,000 kilometers across to roughly 20 kilometers, an entire planet. Compressed into something you could drive around in less than an hour. Now imagine standing nearby. Actually, don't imagine that either. You wouldn't survive long enough to appreciate the view. The gravity near a neutron star is almost incomprehensibly powerful. If you got too close feet first, the gravity pulling on your feet would be dramatically stronger than the gravity pulling on your head. This difference would stretch you apart. Scientists have a wonderfully cheerful name for this process, spaghettification, which sounds like an Italian restaurant. It's actually one of the least enjoyable experiences physics can offer. Your body would become, well, more noodle than person. Even light struggles around these objects. Time itself behaves differently in such intense gravity. Clocks closer to the neutron star tick more slowly than clocks farther away. Einstein wasn't joking. Gravity literally changes time. Which means if someone somehow survived near one, which they absolutely wouldn't, they would age differently compared to someone farther away. The universe looked at time and decided, you know what? Let's make that flexible too. Some neutron stars spin unbelievably fast. Hundreds of times every second. Picture an object heavier than our sun. Rotating faster than a kitchen blender. How? Conservation of angular momentum. It's the same reason figure skaters spin faster when they pull in their arms. Except instead of a graceful Olympic performance, it's a collapsed stellar corpse rotating at ridiculous speed. Some emit beams of radiation from their magnetic poles. As they spin, those beams sweep across space like enormous lighthouse beams. When one points toward Earth, we detect a pulse, 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 pulse. These are called pulsars. For a brief period after their discovery, scientists actually wondered whether the signals came from intelligent aliens. Instead, it turned out the universe had invented cosmic lighthouses. Then there's the magnetic field. Some neutron stars called magnetars possess the strongest magnetic fields known in the universe. Strong enough that if one came close enough to Earth, it could seriously disrupt electronics from unimaginable distances. Thankfully, the nearest ones are comfortably far away. Comfortably in astronomy, meaning distances your brain refuses to visualize. The strangest thing about neutron stars is that they are balanced on a knife's edge. Add enough extra matter, and they collapse again. This time becoming something even worse, a black hole. It's as if the universe keeps asking, can I compress this even more? And gravity keeps answering, absolutely. If you somehow saw a neutron star up close from a magically safe observation deck, It probably wouldn't look huge. It would look surprisingly small. A brilliant, impossibly dense object with gravity so extreme that reality itself begins behaving differently nearby. That's the unsettling part. The most terrifying objects in space aren't always the biggest. Sometimes they are simply the densest. Basically, neutron stars are what happens when gravity decides that atoms have been getting a little too comfortable, and somehow, gravity wins. Imagine looking out the window of your spaceship. You expect to see stars, maybe a colorful nebula, maybe a planet instead. There's a perfect circle of absolute darkness hanging in front of you. Not because it's painted black. Not because the lights are off. Because the universe itself seems to be missing. Your brain immediately starts screaming. That's not supposed to happen. And your brain would be correct. Welcome to the shadow of a black hole. One of the creepiest sights the universe has ever produced. People often imagine black holes as giant vacuum cleaners, sucking up everything nearby like some cosmic monster with an eating disorder. They are actually stranger than that. A black hole isn't really a hole. It's a place where gravity has become so incredibly strong that nothing, not even light, can escape once it crosses a boundary called the event horizon. Think about how weird that sentence is. Light. The fastest thing in the universe. The thing that lets you see literally everything, can't get out. It's as if reality reached a point where even the escape instructions stopped working. Now here's the disturbing part. You can't actually see a black hole itself. It's invisible. What you see is its shadow. Light from glowing gas behind the black hole gets bent around it by gravity. Some rays loop around, some escape, others disappear forever. The result is a perfectly dark circle surrounded by a glowing ring of superheated gas. It's beautiful. In the same way that standing next to an erupting volcano is beautiful, spectacular. But perhaps not a great long-term plan. The first real image of a black hole's shadow shocked a lot of people, not because it looked fake, because it looked exactly like something your brain labels as deeply wrong. Humans are very good at recognizing patterns. We're used to light behaving sensibly. Shadows appear behind objects. Light travels in mostly straight lines. A black hole ignores those rules. Light curves, images distort, the background wraps around. Stars appear where they shouldn't. It's like someone quietly edited the laws of perspective while nobody was looking. Imagine placing a glass marble over a photograph. Everything behind it bends. Now imagine replacing the marble with an object so massive that it warps space itself. That's much closer to reality. Black holes don't simply bend light, they bend space. And because light travels through space, it follows the curve. Which means the universe itself becomes a funhouse mirror. A terrifying billion-ton funhouse mirror. Suppose you were somehow watching another spaceship approach the event horizon from a safe distance. Something incredibly bizarre would happen. The ship would appear to slow down more and more. Its clocks would seem to tick increasingly slowly. Its light would become redder, dimmer. Eventually, it would appear almost frozen near the edge. Not because time stopped for the people inside. For them, everything feels normal. But gravity changes how time passes between different observers. The closer you are to extreme gravity, the slower your time flows relative to someone farther away. Imagine missing your dinner reservation because gravity decided your watch needed a different opinion. The people inside the spaceship wouldn't notice anything special as they crossed the event horizon, assuming the black hole was large enough. That's one of the strangest facts of all. There's no giant warning sign. No glowing line painted across space. No alarm that says, "Congratulations, you've just entered the point of no return. 1 second you're outside, the next second, you're not." And there's no turning back. That's somehow scarier than a dramatic explosion. Reality simply closes the exit behind you. Then comes gravitational lensing. This effect can make objects behind a black hole appear above it, below it, or even wrapped around it. If you looked carefully enough, you might even see the back of your own spaceship, because light from behind you had curved around the black hole and returned to your eyes. Imagine seeing your own rear bumper without using mirrors. Your brain would probably file a formal complaint. Even the glowing gas around black holes behaves strangely. As matter spirals inward, it heats to millions of degrees. The accretion disk shines brighter than entire galaxies. Ironically, one of the darkest objects in existence is surrounded by some of the brightest material in the universe. It's like the world's most dangerous campfire, looks warm, absolutely not recommended. Movies often show people getting sucked into black holes like they are falling down giant drains. Reality is slower and somehow creepier. If you drifted too close, gravity wouldn't instantly yank you in. You'd simply reach a point where every possible future leads inward. The escape routes disappear one by one until there aren't any left. It's less like being grabbed, and more like discovering every road out of town has quietly vanished. Basically, a black hole doesn't chase you, it simply waits. And if you wander too close, the universe politely informs you that outside is no longer an available destination.